Hello guys, this is the lecture number 2 of the chapter linear equation in two variables. So in the previous lecture I discussed everything about what is a linear equation and how this is different from the quadratic equation, biquadratic, cubic equation, and why this equation is called the linear equation. That everything we have discussed, and what's the meaning of the solution of the linear equation, and if you're getting a solution, and what is the geometrical interpretation that we have already discussed in the previous lecture. So now we are going to discuss the geometrical interpretation of all the three conditions of linear equation in two variables. So there are three conditions. So the very first condition is the two lines will intersect at one point. You will be given two equations, and when you draw the lines on the graph, so the lines will be intersecting to one another at one point. So this is one of the condition. The next condition is the two lines will not intersect. That means the lines are parallel. So if the lines are parallel, that means no solution exists. That means you cannot solve the equations. And the very third condition is if the two lines coincident. The two lines are coincident. Alright. So if we understand geometrically, like for the very first condition, the two lines will intersect at one point. Suppose if I draw two lines, this line and this is another line. So these lines are intersecting to each other at one point. So this is the one point, this intersecting point. Suppose the equation of this line is a1x plus b1y plus c1 equal to 0. Okay, and the equation of the another line is a2x plus b2y plus c2 equal to 0, and this is the equation of the another line. Alright, and these lines are intersecting at one point. So when you simplify this both the equation, you will be getting only one value of x and one value of y. Only one value you will get of x and only one value you will get of y. And this is also called the unique solution. Unique means no other value you will get for x and y. Only the single one value, like x equal to 1 and y equal to 2, or x equal to 3 or y equal to 4, like just single solution, and that is a unique solution. That is not going to be changed. Like if you are solving in different way and you're getting the different values of x and y, that is not possible. So the unique values you will get. Alright, and what is the unique values? The intersecting point of both the lines, that is the unique values. And the two lines will not intersect. That means the lines are parallel. Suppose these are the two lines of two equations, and now you see these lines are not intersecting to each other. Okay, so that means if they do not intersect, so that means there is no solution exists for the system of equation. When the solution exists when the line intersect. Until they intersect, you cannot find out the values of x and y. So as you see, the lines are parallel, they're not meeting to each other, so no solution exists. In that case, you will leave the question and write the statement no solution exists as the equation of the lines are parallel. And the very third condition is the two lines will be coincident. Coincident means their path is same. I show you here. Give a second. See, if you draw a line, okay, this is the equation of one line, and if you draw another line, that means the path is same. And what about the solution? As the path is same, okay, there is no condition like they're intersecting, there is no condition like they're parallel. So what you can say about that? So in this kind of case, infinite number of solutions exist for the system of equation. Alright, so I will explain once again. We have three conditions. The very first condition is the lines are intersecting. The second condition is the lines are parallel. In this case, no solution exists. And the third condition is the lines are coincident. You can say the lines are overlapping to each other. Alright, so once again I'll show you all these three conditions geometrically. Just look at this is the intersecting lines, and these are the parallel lines, and this is the condition for the coincident line. The lines are coincident. You see over here, one line goes that way and the another line goes that way. So you see the figure, the line overlap to each other. So but what happens if the two equations are given? Then how we can find out which of the conditions is going to be satisfied, and which condition is to be applied? How we can know after just looking at the equations? So there are three conditions. So I just tell you all these three conditions. So this is a chart we have made to make you understand all the three conditions. See, I took an example. So this is one line, x minus 2y equal to 0, and this is the equation of the another line. Alright, suppose this question is given in the question paper, then what to do? So first of all, we have to check which is the condition going to be satisfied. Alright, so there are three conditions: the very first condition, the second condition, and the third condition. Alright, so when the a1 upon a2, I already told you what is the a1 and what is the a2 in my first lecture. If the a1 upon a2 does not equal to b1 upon b2, if this condition comes out, so you say the lines are intersecting. The lines are intersecting this way. They intersect at one point, and the unique solution exists. Unique means only one solution exists for this one. Alright, and let the another condition: 2x plus 3y minus 9 equal to 0, and 4x plus 6y minus 18 equal to 0. Okay, and if this condition comes out, a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Okay, if these all the three ratio comes equal, so you say the lines are coincident and infinitely many solutions exist. Alright, and if this condition comes out, like the very first two ratios are equal and they're not equal to the third ratio, like they're not equal to the c1 upon c2, so you say the lines are parallel and leave the solution there because you can't solve. So let's discuss the very first condition. x minus 2y equal to 0, and the second condition is 3x plus 4y minus 20 equal to 0. Okay, and your a1 is the coefficient of x, and the b1 is the coefficient of y, which is minus 2, and what is the c1? As c1 does not exist, so you have to take c1 as 0. For the second equation, your a1 is 3 and b1 is 4 and c1 is negative 20. Okay, so apply the condition, just check it first of all. So we are writing a1 upon a2 because we do not know which condition is going to be satisfied. So I'm not putting any equal to or not equal to sign. b1 upon b2 and this c1 upon c2. Alright, so write the values of a1 upon a2. So what is your a1? Your a1 is 1. And what is your a2? a2 is 3. And what is the b1? Your b1 is negative 2. And what is the b2, which is 4, and your c1 is 0, and your c2 is negative 20. So you see the very first two ratios, these, they are not equal. If they are not equal, just check which is the condition going to be satisfied. So in the only very first condition, where your a1 upon a2 does not equal to b1 upon b2, so the lines are intersecting. Lines are intersecting. Okay, and to find out where the lines are intersecting to each other, how to find out? Just solve both the equation x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0. When you simplify, when you solve both the equation, you will get one value of x and the one value of y. So that are the point where the lines are meeting to each other. So this is the beauty of linear equations. You can find out where the two lines are meeting with each other. So this is the beauty of these all the things. All right. So, but the second problem is how to find out the values of x and y. Like now you know the lines are intersecting, but how to find out the point where the lines are intersecting? So your lines are x minus 2y equal to 0 and 3x plus 4y. Just take your 20 to the right hand side. So this is the equation 1 and this is the equation number 2. Okay, so to get the intersecting point, you would have to solve both the equation, and there are some method which is already given, which is given in the chapter. The name of the methods are elimination method, substitution method, cross multiplication method. All right, and I will be discussing these all the three methods in my next lecture, which is lecture number 3. So please write in the comments if you do not understand anything, or if you want to give some suggestion, and please like and subscribe my channel. Thank you for watching. Take care.